Every great mystery begins with a place, a specific point in the cosmos where the rules of reality seem to bend and the impossible becomes momentarily tangible. For us, that place is the constellation of Sagittarius, the Archer. It is not merely a pattern of distant suns as seen from our tiny world. It is a galactic crossroads, a junction where trajectories from across the Milky Way converge. And it is from this precise direction that researchers have traced the origin of our visitor, the object designated 3I Atlas. This is not a random coordinate. This is the very same patch of sky where, decades ago, the most compelling, unexplained signal in human history tore through the cosmic silence, the wow signal. A coincidence? The astronomers who made this discovery don't think so. The alignment is far too precise, far too laden with implication. It suggests something far more profound than a wandering space rock. It suggests that something, or someone, may have already been reaching for us, that 3I Atlas may have been listening the entire time, waiting in the void. The shock wasn't just the object's interstellar nature, it was the chilling elegance of its origin point. When astronomers traced the orbit of 3I Atlas backward through time, integrating its trajectory across millions of years of galactic motion, they expected to find a parent star system, some stellar nursery or disrupted planetary disk that had naturally ejected this wanderer. What they found instead stopped them cold. The object's path, when rewound like a cosmic film running in reverse, pointed unerringly back to Sagittarius. Not approximately the same region. The Archer's bow, it seems, was aimed directly at Earth. This is not how science is supposed to work. Coincidences happen, but coincidences this precise make you wonder whether you're looking at random chance or something that was designed to be noticed. Three elements are converging here in a way that feels less like an accident and more like a meticulously planned choreography. First, an interstellar object, a confirmed visitor from beyond our solar system, arrives from Sagittarius after a journey lasting potentially millions of years. Second, the strongest candidate SETI signal ever recorded, a 72-second radio burst so powerful and narrowband that astronomer Jerry Amon wrote, "Wow!" on the printout, came from Sagittarius in August 1977. Third, Earth itself has been broadcasting radio signals into space for nearly a century, and those signals, traveling outward at the speed of light, have already reached stars in Sagittarius, announcing our presence to anyone who might be listening. This creates a feedback loop that demands attention. Signals out, signal in, object in. It looks less like three separate events and more like three acts of the same play. A cosmic exchange unfolding across decades and light years, with Earth as both the sender and the receiver. If this mystery has you hooked the way it has me, if you feel that chill of recognition, that sense that we are on the precipice of something universe-altering, then I need you to stay with me. Make sure you don't miss a single update as this story unfolds in real time. Wherever you are in the world, drop a comment below. Tell me what time it is there and where you're watching from. I want to map our own little community of cosmic detectives, and if you want to help this community grow, share this video. You are the reason we can keep chasing stories like this, so thank you for having our back. Now let's dive into the shock opening of this discovery, because what they found in that orbital data is only the beginning of the terror and the wonder. Tracing an object's orbit backward through time is detective work on a cosmic scale, a discipline known as orbital forensics. Astronomers start with the object's current position and velocity, precise measurements taken from multiple observations as it moves across the sky. They feed this data into sophisticated simulations that model the gravitational influences of every significant mass in the galaxy. The Sun, the planets, nearby stars, the galactic disk itself, even accounting for the cumulative tidal effects of the dark matter distributed throughout the Milky Way. The simulation runs backward, calculating where the object would have been last year, last century, last million years, integrating through all the gravitational perturbations that would have affected its path. If the object originated from a stellar flyby or was ejected from a planetary system, this backward integration should eventually bring it close to a star that could plausibly be its parent. The Gaia Space Telescope has revolutionized this work. Its data contains precise positions, distances and velocities for over 1 billion stars. For the first time, we can reconstruct the three-dimensional motion of our stellar neighborhood across millions of years. When 2I Borisov was discovered in 2019, Researchers used Gaia data to trace its origin to a young stellar association. The match wasn't perfect, but it was plausible. Borisov was a pristine comet, ejected from a planetary system during its formation, and its story made sense. 3i Atlas offered no such comfort. Researchers checked dozens of stellar encounters, running the integration backward, looking for close approaches to stars that might have hosted the object once. They found nothing. No star came close enough to 3i Atlas's reconstructed path to be a plausible parent. Some encounters were marginally interesting, but were ruled out by velocity mismatches. The object would have needed impossible acceleration to escape from those systems. Others were ruled out by timing. The further back the integration ran, the more scrambled the orbit became, affected by galactic tides and cumulative perturbations from distant masses. Eventually, the uncertainties grow so large that you can't reliably say where the object was millions of years ago. This is unprecedented for an interstellar object. We expect these visitors to be traceable, at least in principle, because they came from somewhere. 3i Atlas breaks the pattern. Its orbit doesn't trace to anything obvious, creating two competing explanations, and neither is comfortable. The first is that the object is extraordinarily old, ancient beyond our ability to reconstruct its history. A fossil from stellar systems that might not even exist anymore. The second explanation is that the trajectory was never natural in the first place. Sagittarius dominates our view of the galactic center. When you look toward the Archer constellation, you are peering through the densest concentration of stars in our entire galaxy, toward the supermassive black hole that anchors the Milky Way's rotation, toward the bulge where stellar populations crowd together in configurations impossible in our quieter spiral arm. This is the cosmic downtown, the metropolitan core where gravity runs strongest and matter collects in extraordinary densities. Star-forming regions blaze with ultraviolet radiation from newborn stellar clusters. Ancient red giants, billions of years old, drift in orbits that have circled the galactic center hundreds of times. The region is everything: nursery and graveyard, construction site and ruin. This density makes Sagittarius a natural meeting point, a crossroads where trajectories from across the galaxy might plausibly intersect. If you wanted to position a monitoring station or a relay node where it would have maximum exposure to passing civilizations, where the probability of eventually encountering another technological species was highest, the galactic center region would be the obvious choice. More stars mean more planetary systems, which means more chances for life and intelligence to arise. The region has been churning out stars for the entire history of the galaxy, meaning any civilizations that evolved there had a head start measured in billions of years. By the time humanity's ancestors were single-celled organisms, civilizations in Sagittarius could have been ancient, could have spread throughout the region, could have established infrastructure we're only now becoming capable of detecting. The statistical odds of 3i Atlas pointing towards Sagittarius by pure chance depend on how you frame the question. The sky contains 88 constellations. Sagittarius is large, so any given direction has maybe a 5 or 10% chance of falling within its boundaries. That doesn't sound particularly unlikely. But when you add the wow signal, when you specify not just any constellation, but the constellation that produced the most significant SETI candidate ever detected, the odds tighten considerably. And when you add Earth's broadcast history, when you specify the constellation we've been inadvertently signaling for decades, the coincidence becomes harder to dismiss. You're not asking, what are the odds of pointing toward any constellation? You're asking, what are the odds of all these elements aligning toward the same constellation? And that's a much more constrained question. The convergence is what creates urgency, what transforms orbital forensics from an academic exercise into a potential first contact scenario. August 1977 was an extraordinary month for humanity's relationship with the cosmos, though we didn't understand that at the time. Two events occurred, separated by mere days, that would later seem less like coincidence and more like profound symmetry. Two notes in a larger composition we're still trying to hear clearly. On August 20th, NASA launched Voyager 2, a robotic probe designed to study the outer planets and then continue into interstellar space, carrying a golden record encoded with images, music, and greetings from Earth in 55 languages. The spacecraft's trajectory would eventually take it toward the constellation Sagittarius, carrying our message outward. 5 days earlier, on August 15th, the Big Ear radio telescope detected the WOW signal. The timing creates a bookend effect that's impossible to ignore once you see it. Earth sends a physical probe outward, aimed towards Sagittarius. And almost simultaneously, we receive what remains the strongest candidate radio signal for extraterrestrial intelligence, coming from Sagittarius. Message out, message in, launch and detection. The symmetry would be poetic if it weren't so unsettling, if it didn't suggest that maybe, just maybe, these events weren't independent. Maybe someone or something was watching, noticed our preparations to send Voyager, and responded immediately with a signal timed to arrive just before the launch. A cosmic whisper saying, "We see you. We're here. We're in the direction you're sending your probe." Voyager 2's golden record represents humanity's most deliberate attempt at cosmic communication before that point. It contains 116 images, 90 minutes of music, greetings in 55 languages, and whale songs. It is a message in a bottle, thrown into an ocean so large that recovery seemed impossible. We did it not because we expected results, but because the act of creating the message mattered. Fast forward to today. Voyager 2 is now in interstellar space, heading towards Sagittarius, and 3I Atlas came from Sagittarius. One object outbound, one inbound, both connecting to the same region of space. Their paths cross in conceptual space, even if they never intersect physically. We're sending an artifact of our civilization into the cosmos, and the cosmos might have sent one back. We are left suspended between two explanations for 3I Atlas, and the choice between them shapes everything that follows. On one side, the natural explanation. Interstellar objects are common. 3I Atlas is just one of these, notable because we spotted it, but ultimately just a rock. Its trajectory towards Sagittarius is coincidental. Its apparent untraceability is because it's ancient, or because our models aren't sophisticated enough yet. The wow signal connection is pattern-seeking. Humans finding meaning where only randomness exists. This explanation is conservative, fits established physics, and requires no new assumptions about alien civilizations. It's the explanation most scientists default to because extraordinary claims require extraordinary evidence, and we don't have that evidence yet. On the other side, the engineered explanation, 3I Atlas, is an interstellar probe deliberately sent to our solar system, possibly part of a larger network of monitoring devices. Its trajectory was calculated, not random. Its timing is intentional. Its connection to Sagittarius and the wow signal is real. The probe is disguised as a natural object because that's what you do if you want to observe without causing panic, to let the target civilization gradually discover you. This explanation requires accepting that another technological civilization exists, has interstellar travel capability, has been monitoring us, and chose this moment to make contact in a way subtle enough that we have to work to see it. The probe hypothesis isn't new. Since the 1960s, physicists have proposed that advanced civilizations might use autonomous probes rather than radio signals for interstellar communication. Probes travel slower but carry more information, can adapt to local conditions, and can watch and wait for civilizations to develop technology before revealing themselves. A galaxy-spanning network of such probes could create an interstellar internet. This is the dilemma that sits at the center of this investigation. Natural or artificial, coincidence or design, alone or watched. The questions don't have answers yet, but they have implications that cascade through every observation, every analysis. When the James Webb Space Telescope turned its infrared sensors toward 3I Atlas during the object's passage through the inner solar system, astronomers expected to see spectral signatures similar to 2I Borisov, water ice, carbon monoxide, carbon dioxide, organic compounds in ratios matching solar system comets. Borisov was exciting because it was normal. It proved that the processes happening in our stellar nursery weren't unique. 3I Atlas did not cooperate. The spectroscopy revealed an unusually high carbon dioxide to water ratio. Most comets are primarily water ice with smaller amounts of other volatiles mixed in. 3I Atlas showed the inverse pattern. Lots of carbon dioxide, relatively less water. This isn't impossible naturally, Comets that formed in colder regions of their parent protoplanetary disk could develop this composition. But it is unusual. Finding this rarity in one of the handful of interstellar objects we've studied raises questions. The coma, the cloud of gas and dust surrounding the nucleus, appeared compact and structured. Normal comets develop large diffuse comas as solar heating turns ice into gas. 3I Atlas's coma was smaller than expected for its brightness, suggesting either unusual sublimation physics or a nucleus with different thermal properties. Some researchers noted that the coma's shape and density fluctuations looked almost regulated, as if the outgassing was being controlled rather than occurring naturally. This observation is disputed, but is part of the growing constellation of details that don't quite fit standard models. Comparing 3I Atlas to its interstellar predecessors reveals a spectrum of strangeness. 1I Oumuamua showed non-gravitational acceleration with no visible signs of outgassing, sparking debates about artificial origins. 2I Borisov was refreshingly normal. Its normality makes 3I Atlas's differences more pronounced. If most interstellar comets are like Borisov, why isn't Atlas? The debate over artificiality hinges on defining what evidence would be sufficient. A hybrid possibility occupies the middle ground. A natural comet modified by engineering. A Trojan horse probe disguised in actual cometary material. This would explain why 3I Atlas shows some comet-like behavior, while also displaying oddities that don't fit pure cometary models. The core might be technology, wrapped in a shell of ice and rock. The chemical anomalies matter because they are measurable, reproducible data points. Either the carbon dioxide to water ratio is unusual, or it isn't. These are questions that can be answered with better data. The problem is that 3I Atlas is already leaving, moving beyond the range of our best instruments, and we may have missed our best chance to prove what it truly is. If 3I Atlas is ancient, if its orbit has been scrambled by millions or billions of years of galactic motion to the point of untraceability, then we might be looking at something profoundly sad. Debris from a civilization that no longer exists. This is the orphaned probe hypothesis, and it carries an existential weight that pure natural explanations do not. A rock is just a rock, but a machine outliving its creators, still executing commands from minds that turned to dust billions of years ago. That is genuine tragedy on a cosmic scale. The thick disk of our galaxy contains its oldest stellar populations, stars that formed within the first few billion years after the Milky Way coalesced. If 3I Atlas originated from that population, if it was launched by a civilization that evolved around one of those ancient stars, it could easily be untraceable by now. The parent star might have drifted thousands of light years from its original position. The civilization is likely extinct. This creates the concept of galactic archaeology, studying the ruins not of human civilizations, but of alien ones, piecing together their history from the artifacts they left behind. The cosmic graveyard hypothesis extends this. The galaxy is littered with defunct technology from civilizations that rose, flourished, and fell across billions of years. Most of it is unrecognizable, degraded by radiation and impacts until it's just strange metallic debris. Some of it might still be functional, running on power sources that last geological epochs, continuing missions long after their purpose became meaningless. Probes drift through interstellar space, occasionally passing through stellar systems, photographing planets, recording data that goes nowhere because the receivers no longer exist. This is contact, not with living intelligence, but with its ghosts. The parallel to our own Voyager probes is inescapable. They will outlive humanity, carrying our golden records into a future where Earth is ancient history. If another civilization encounters Voyager, they'll be discovering our ruins. If 3I Atlas is an ancient probe, it might be our Voyager equivalent from someone else's civilization. They launched it with hope and purpose, but the timescales defeated them. This raises a chilling question. Are the interstellar objects we're discovering actually dead technology rather than natural debris? Oumuamua's weird acceleration could be a derelict probe's damaged propulsion system. Borisov might be an old probe whose exterior accumulated enough ice and dust to look like a comet. 3I Atlas's compositional oddities could be remnants of manufacturing. We'd never know because we lack the resolution to examine them closely enough. The implications are profound. It suggests the Fermi paradox has a dark answer. Civilizations are common, but they don't last long enough to make direct contact. The galaxy is full of intelligence on timescales too slow for individuals to meet. We're all just passing notes to the future, hoping someone reads them eventually. Earth has been accidentally broadcasting its presence to the cosmos for approximately 100 years. Every AM radio transmission, every television broadcast, every radar pulse leaks into space at the speed of light, spreading outward in an expanding bubble now roughly 200 light-years in radius. This bubble encompasses thousands of stars, including multiple candidates in Sagittarius. Our signals are not uniform. Early radio was weak. Television broadcasts are stronger, but encoded in changing formats. Military radar is our brightest emission, powerful pulses designed to track missiles, but equally effective at announcing our presence to anyone monitoring the radio spectrum. If we calculate which stars in Sagittarius have already been reached by our emissions, the numbers are unsettling. Stars within 100 light-years would have received signals from the 1920s and 30s. Stars within 50 light-years would have received our stronger television, signals from the 1950s and 60s. The timing creates a feedback loop. The WOW signal was detected in 1977. If it was a deliberate transmission, the civilization sending it would have needed to receive our emissions, recognize them as artificial, decide to respond, and transmit back. Light-speed communication means round-trip time equals twice the distance. If the source was 25 light-years away, they'd have received our 1950s broadcasts in the 1970s. Plenty of time to detect us and respond before we detected them in 1977. The possibility that WOW was a reply, an acknowledgement of our presence, transforms it from an unexplained mystery to the first successful exchange in human-alien communication. We whispered accidentally. Someone heard and whispered back deliberately. The signal's brevity makes sense in this context. They weren't trying to send complex information. They were saying hello, confirming reception. The fact that it never repeated fits too. Once they confirmed we heard them, they went silent, waiting to see what we'd do next. What we did next was mostly nothing. We logged it as an anomaly, tried to find it again, failed, and eventually filed it away. We didn't mount a comprehensive response. But if the WOW signal was them saying hello and we said nothing back, they might have decided to send something physical instead. Radio is fast but limited. A probe is slower but more versatile. 3i Atlas arriving decades after the WOW signal fits this interpretation perfectly. The signal was phase 1. Hello. The probe is phase 2. Detailed study. The SETI mirror concept suggests that searching for extraterrestrial intelligence and being found by them are the same process viewed from different angles. We've been broadcasting loudly and accidentally for a century. The question isn't whether we've been found. The question is what happens next. Beneath the official narratives of interstellar object discoveries and SETI detections runs a dark current of speculation. Claims that intelligence agencies and black-budget programs have been tracking unusual objects in deep space for decades. That Oumuamua wasn't the first interstellar visitor, but simply the first one they couldn't keep secret. That our telescopes have detected numerous anomalous objects whose data was classified before reaching the scientific community. These claims exist in the shadowy space between conspiracy theory and whistleblower allegation. The allegations typically follow a pattern. Defense-related telescopes, the ones tracking satellites and space debris, occasionally detect objects with trajectories that don't match anything in their catalogues. When the conclusion is that an object is interstellar, the data gets classified. The official record shows nothing. The researchers involved are bound by security clearances. Proponents point to the sudden official acknowledgement of UAPs, unidentified aerial phenomena, by military and intelligence agencies as a precedent. The narrative shifted from "these don't exist" to "these exist, but we don't know what they are." If governments can keep UAP investigations secret for decades, why not interstellar objects? The motivation for suppression would be multiple. Preventing public panic, maintaining strategic advantage, buying time to understand what's happening before making announcements that can't be walked back. Contact with extraterrestrial intelligence is arguably the most significant event in human history. Governments might reasonably decide that revelation should be controlled and gradual. This logic is sound, which makes these theories harder to dismiss. The allegation that 3i Atlas is part of a larger catalogue of suppressed detections fits this framework. It might be one they couldn't keep secret because too many civilian observers detected it independently. we might be seeing only the tip of the distribution, while a larger population of detections remains locked in classified databases. Mainstream scientific rebuttal focuses on the practical difficulties of maintaining such secrecy across international borders. But limited suppression isn't implausible. You don't need to hide everything from everyone. You need to identify the most sensitive data and classify that narrow subset. This creates a two-tier system: public astronomy studying natural phenomena, and classified astronomy studying potential techno-signatures. Whether this actually happens remains unproven, but the speculation shapes how people interpret events like 3i Atlas, creating a perception that the public story is a sanitized version of a more complex and disturbing truth. The three elements converge with timing so precise it feels choreographed. Outbound message, inbound signal, inbound object. Voyager 2 launched in August 1977, carrying humanity's golden record towards Sagittarius. The WOW signal arrived weeks earlier from Sagittarius. 3i or Atlas appears decades later from Sagittarius, compositionally unusual, orbitally untraceable, arriving exactly when humanity has developed the technology to study such objects seriously. Each element individually could be random. Together they sketch a pattern that suggests coordination. The cosmic relay hypothesis proposes that what we're seeing isn't coincidence, but infrastructure, a network of monitoring nodes positioned throughout the galaxy, watching star systems, detecting when technological civilizations emerge, and responding according to protocols we don't understand. These nodes might be ancient, placed millions of years ago by civilizations that have since transcended or vanished. They wait, silent and patient, until techno-signatures appear. Radio broadcasts, nuclear detonations, orbital satellites. When the signature crosses a threshold, the node activates. Activation might proceed in stages. Stage 1. Passive observation intensifies. Stage 2. Initial signal. A brief transmission designed to be noticed but ambiguous enough to be dismissed. A test. Does the civilization notice? Do they respond? The WOW signal fits stage 2 perfectly. It was brief, 72 seconds, on the hydrogen line frequency, strong and never repeated. Its purpose was confirmation, not communication. They were saying, "We see you." One ping, then silence, waiting for your response. We didn't respond coherently. Decades passed. Then 3i Atlas arrives. Stage 3, physical proof, hardware we can analyze. If this is choreography, it's patient choreography, operating on timescales that span human generations. Why Sagittarius as the hub? The galactic center is the densest stellar environment, maximizing detection probability. It is geometrically central, an efficient relay point. The supermassive black hole provides a potential energy source, and the region is astronomically significant to any species that develops telescopes. The galactic internet concept extends this: a connected network sharing data about detected civilizations. Earth's detection triggers notification throughout the network. We're added to the catalog, marked as an active, monitored system. This reframes the search for extraterrestrial intelligence from "are they out there?" to "how do we access the network we're already part of?" The signals aren't necessarily from distant civilizations. They could be from infrastructure in our own stellar neighborhood. The choreography continues. 3i Atlas is leaving. We studied it, debated it. Maybe that was the test. Our response, or lack thereof, gets logged. And based on that, decisions are made about what happens next. In 2025, machine learning algorithms achieved something human astronomers had been attempting for decades. They found patterns in stellar motion data that suggested previously undetected close encounters between the Sun and nearby stars millions of years ago. Artificial intelligence systems, trained on the vast Gaia data catalog, integrated orbital trajectories backward through time, accounting for complex gravitational perturbations. The AI identified stellar flybys that human analysts had missed. This breakthrough demonstrates AI's power for pattern detection in high-dimensional data sets, too complex for human analysis. Humans can examine hundreds or thousands of trajectories. AI can examine millions, finding correlations and coincidences that no human would spot. Applied to interstellar objects, AI could revolutionize our understanding. Current analysis involves human researchers manually checking trajectories. An AI could check billions of possible trajectories, exploring parameter spaces humans can't access. More intriguingly, AI might detect a pattern humans are blind to: a distribution of interstellar object origins that clusters in certain directions or shows periodicities, suggesting artificial scheduling rather than random arrival. If probes are being deployed according to a pattern, a monitoring grid with nodes spaced at regular intervals, that pattern would be invisible to humans analyzing objects one at a time. But AI examining the complete data set might see the structure. This possibility is both exciting and concerning. Exciting because we might discover the probe network through pure data analysis. Concerning because AI might find patterns that don't exist, hallucinating structure in noise. The possibility that aliens use AI themselves introduces another layer. If monitoring probes are AI-governed, then first contact might be machine to machine. Our AI might detect their AI, beginning to communicate in languages neither species fully understands. We're entering the AI cosmos race, the competition to develop artificial intelligence sophisticated enough to manage the complexity of searching for extraterrestrial intelligence. SETI has always been computationally intensive. Modern SETI might need to find artificial patterns in data that looks entirely natural until examined from the right mathematical perspective. The speculative scenario is that AI finds a trail of interstellar objects, dozens of them, collectively forming a pattern that suggests deployment from a fixed location. Proving it requires demonstrating that the pattern is real and not an artifact of our observational biases. The question becomes, if AI found such a pattern, would we believe it? We're entering an era where discoveries will be AI native, found by algorithms that humans can verify computationally but can't intuitively grasp. This creates epistemological challenges. How do we trust discoveries we don't understand directly? What's certain is that AI will transform cosmic investigation. And if intelligence exists elsewhere, if probes are monitoring us, AI might be our best hope of finding them before they choose to reveal themselves more obviously. Deep underground, in laboratories shielded from cosmic rays, experiments like Xenont sit waiting for dark matter particles to reveal themselves. They have not yet made a direct detection, despite decades of increasing sensitivity. Dark matter is the invisible mass that comprises 85% of the matter in the universe, affecting everything through gravity, but passing through normal matter almost without interaction. The connection to interstellar objects becomes intriguing when you consider how dark matter might affect trajectories over millions of years. Objects traveling through interstellar space would experience tiny gravitational tugs from dense clumps and filaments of dark matter, perturbations too small to detect directly, but potentially significant over interstellar distances and timescales. This offers a possible natural explanation for why 3I Atlas's orbit is untraceable. If dark matter interactions subtly deflected its path, backtracing using only visible matter's gravity would fail. But there's a fringe speculation, more intriguing and less likely. What if interstellar probes exploit dark matter deliberately? If advanced civilizations understand dark matter better than we do, they might use dark matter structures as navigation aids or even propulsion assistance. Imagine a probe calculating its trajectory to pass through dense dark matter filaments that provide gravitational assists, curving the path without requiring onboard propulsion. Or imagine probes that can interact with dark matter through physics we haven't discovered, surfing invisible currents that pervade the galaxy. This is highly speculative, but it connects multiple mysteries. From our perspective, a probe using dark matter navigation would seem to curve and accelerate inexplicably. We'd see anomalous velocity changes, trajectories that violate conservation laws according to our incomplete physics. Oumuamua's acceleration might be exactly this. 3I Atlas's untraceable orbit might reflect dark matter navigation calculated millions of years ago. Scientists would caution that these ideas lack evidence. Occam's razor favors simpler hypotheses, but simplicity is subjective. Is it simpler to assume an object is billions of years old with a perfectly scrambled orbit, or to assume it was deliberately guided using unknown physics? Different people will judge those options differently. What's undeniable is that dark matter is real, poorly understood, and potentially relevant to how objects move through interstellar space over long time scales. Connecting these cosmic mysteries creates a more integrated view of cosmology, where different research programs inform each other. In orbit above Earth, quantum entanglement satellites are performing experiments that prove quantum communication is viable for space applications. They have demonstrated entanglement distribution across continental distances, maintaining quantum coherence between photon pairs separated by thousands of kilometers. This is the foundation for quantum networks, communication systems that exploit quantum mechanics to achieve things classical systems can't, like theoretically unbreakable encryption. The dream extends far beyond secure key distribution. Quantum networks might eventually enable distributed quantum computing over interplanetary distances or quantum sensing arrays with unprecedented resolution. If humanity is testing this in 2025, civilizations millions of years ahead might have perfected it, scaling it to galactic distances. This suggests a profoundly unsettling possibility. Extraterrestrial civilizations might be communicating constantly through a galaxy-wide quantum network, and we simply can't detect it because quantum communication leaves no classical signature. A quantum network would be invisible to anyone not already part of it. A galactic darknet, humming with information exchange that civilizations without quantum technology couldn't even confirm exists. This reframes the Fermi paradox. We ask, where is everybody? While assuming communication happens through electromagnetic radiation. But what if mature civilizations transition to quantum communication precisely because it's more efficient, secure, and invisible to outsiders? From their perspective, radio is primitive and insecure. They stopped broadcasting electromagnetically eons ago. We don't detect them because we're listening in the wrong domain, using obsolete technology. The wow signal takes on new meaning in this context. Maybe it wasn't a message. Maybe it was leakage, an accidental signal from a quantum communication system briefly coupling to classical electromagnetic fields due to a malfunction. Its brevity and uniqueness fit this interpretation. We glimpse something we weren't meant to see. If 3i Atlas is part of this quantum infrastructure, a quantum repeater or node, then studying it with classical instruments would tell us almost nothing about its real function. Its true nature would be invisible unless we developed quantum sensors sophisticated enough to detect entanglement signatures without collapsing the quantum states. We might be surrounded by a conversation happening in a language we are deaf to. The universe is not silent. In 2015, the first detection of gravitational waves confirmed that the fabric of space-time itself ripples from cosmic catastrophes like black hole mergers. Since then, observatories like LIGO and Virgo have been listening, and the data has transformed our view of the galaxy. Now, a new frontier is opening. Scientists are beginning to use these waves to chart the galaxy itself, mapping invisible structures in space-time. Gravitational waves are ripples in reality. Imagine tossing a stone into a pond, but the pond is space-time itself. Every massive collision sends waves rippling outward. New work is not only detecting these events, but also beginning to chart them. What is emerging is a picture of corridors, natural troughs or grooves in the fabric of the galaxy. If those grooves can be mapped, they could function as galactic shipping lanes. To us, they are still abstract, but for a civilization millions of years ahead, those corridors might be familiar roads. Imagine a spacecraft not pushing against fuel tanks, but slipping into one of these gravitational troughs and letting space-time itself carry it forward, like a surfer riding a wave. This would save enormous amounts of energy. If gravitational waves create stable corridors, then travel across interstellar distances becomes more manageable. This raises a startling possibility about 3i Atlas. Its trajectory appears untraceable. What if that is because its path was aligned with one of these invisible wave corridors? If so, its arrival here is not just luck. It is choreography. The idea of hitchhiking on gravitational waves may sound like science fiction, but the concept is simple in principle. We may be latecomers stumbling onto a galactic map others already know. What looks like chaos to us might look like a highway network to them. When we ask why Sagittarius keeps showing up, why signals and objects point in that direction, perhaps the answer is simple. It lies along one of the main corridors, one of the great arterial routes of the Milky Way. If probes are being sent, they would naturally arrive along these paths. The trajectory of Atlas, the wow signal, the outbound course of Voyager 2, all point towards Sagittarius. If this is design, it suggests we're standing at the edge of a map we did not draw, watching the edges of traffic lanes we do not yet understand. In 2025, Voyager 2 is still moving outward, a tiny spark of human ambition now in interstellar space, heading toward the constellation Sagittarius, and in that fact lies a strange and haunting symmetry, because 3i Atlas came from that same neighborhood. One messenger outbound, one messenger inbound. Voyager 2 carries the golden record, a disk etched with sounds and images of Earth, a message in a bottle tossed into the cosmic sea. We sent it with hope but no expectation of a reply. Yet now, with Atlas's arrival, it feels as though we may already be part of a slow conversation that began before we realized it. The wow signal of 1977, Voyager's launch, Atlas's arrival. Alone, each fact is curious. Together, they form a pattern too neat to ignore. One message out, one message in, one object in between. Perhaps it is coincidence, or perhaps it is choreography, on a timescale too vast for us to grasp. The mirror is not only scientific but philosophical. We're so accustomed to thinking of ourselves as alone, as isolated actors casting signals into a void. But what if we're already inside a dialogue, only too impatient to hear the full sentence? Civilizations lasting millions of years would not communicate in minutes or days. They might communicate in epochs. A probe sent 1,000,000 years ago could still be arriving now. A reply to our radio broadcast might not return for another 10,000 years. What feels like silence to us might be conversation to them. Voyager's golden record is a message of who we are. Optimistic, filled with music and greetings. If Atlas is a message, it is silent, mute, a puzzle. We shout into the void with symbols and songs. They speak by moving stone and ice across the stars. Which method is more patient? Which is wiser? This is the cosmic mirror. Voyager 2 represents us, a species just learning to speak to the galaxy. Atlas represents the other, an arrival that forces us to wonder if we are being observed or if we have stumbled onto the relics of others long gone. Together, they remind us that we are not just observers of the cosmos. We are participants, whether we want to be or not. We've entered the stage, and the stage may already be occupied. The final thought is sobering. Atlas may not be proof of aliens. It may be random, ancient, and meaningless, but it has forced us to look differently at ourselves, to realize that when we send probes, signals, and records into space, we are not just exploring. We are joining a conversation that may have been going on for millions of years. We are the new voices in a very old room. The Fermi paradox asks a simple question. If the universe is so vast and old, where is everybody? The silence is deafening. The traditional answers are grim. Perhaps civilizations destroy themselves before achieving interstellar travel. Perhaps life is rarer than we think. Perhaps we're the first. But what if the answer is simpler and more unsettling? What if the silence is not silence at all, but a conversation happening on timescales we can't perceive? If civilizations last for millions of years, their communication would not be rapid fire. A message might take 10,000 years to reach its destination. A reply might take another 10,000 years. From their perspective, this is normal conversation. From ours, it's indistinguishable from silence. We've been listening for radio signals for less than a century. In cosmic terms, that's a blink. We're expecting an answer in minutes when the conversation happens over millennia. The Great Filter hypothesis suggests something prevents civilizations from reaching the stars. But maybe the filter isn't destruction. Maybe it's patience. Civilizations that survive long enough learn to think in geological time. They don't rush. They send probes that take 1,000,000 years to arrive. They broadcast signals that repeat every 10,000 years. They build infrastructure that lasts for epochs. With the impatient newcomers, shouting into the void and expecting an immediate reply, the convergence of signals and objects from Sagittarius might be our first glimpse of this slower, grander timescale. The wow signal wasn't a message. It was a single word in a sentence that takes centuries to speak. 3i Atlas isn't a probe. It's a punctuation mark in a paragraph written across light years. We're only now learning to read at this speed. This reframes the entire search for extraterrestrial intelligence. We shouldn't be looking for constant chatter. We should be looking for rare, widely spaced events. A signal every few decades, an object every few centuries. The pattern emerges not in minutes, but over generations. The data we need might take centuries to collect. This is humbling. It means we might not live to see the answer, but it also means the answer might already be here, embedded in events we've witnessed, but haven't yet connected. The Fermi paradox isn't a paradox of absence. It's a paradox of perception. We're like mayflies trying to understand human conversation by listening for a split second. The conversation is happening. We just need to learn to listen slower. If 3i Atlas is an alien probe, its presence raises urgent ethical questions that humanity is completely unprepared to answer. Who has the right to make first contact? Who speaks for Earth? Is it the scientists who discovered it? The governments that fund the research? The United Nations? All of humanity? Currently, there is no protocol. There are guidelines like the SETI Post-Detection Hub suggestions, but they have no legal force. In reality, the first person to decode a signal or communicate with a probe could become the de facto ambassador for our species, with no mandate from anyone. This is a terrifying prospect. The risks of miscommunication are enormous. A single wrong signal, sent by an individual or a small group, could misinterpret human intentions, provoke hostility, or give away strategic information. Imagine if a corporation attempted first contact to gain proprietary technology, or if a nation-state tried to monopolize the relationship for military advantage. The potential for chaos is extreme. The content of communication matters profoundly. Do we reveal our political divisions, our history of war, our environmental crises? Do we present an idealized version of humanity or the messy reality? The golden record on Voyager presented a hopeful, artistic vision. But is that honest? If the probe is monitoring us, it's already seeing the reality. Our news broadcasts, our internet, our conflicts. Deception might be impossible. The deeper ethical question involves our own future. Contact with a superior intelligence could shatter human culture, religion, and self-perception. It could cause widespread panic or despair. Do we have the right to make that decision for everyone? Or should contact be avoided until we're more mature as a species? There's no clear answer. The discovery of 3i Atlas, if it is artificial, forces these questions from abstract philosophy into immediate policy. We need international agreements, transparent processes, and a consensus on how to proceed. Because the next signal might not be a mystery. It might be a hello, and we need to be ready to say hello back, wisely. Human civilization operates on timescales of years, decades, centuries at most. Our institutions, our plans, our very consciousness are built around brevity. But the cosmos operates on timescales of millions and billions of years. If intelligent life exists elsewhere, it almost certainly thinks on these deeper scales. Civilizations that survive for millions of years would be fundamentally different from us. Their projects would be geological. Their art might unfold over millennia. Their conversations might have pauses lasting centuries. They would see the universe not as a place to conquer quickly, but as a home to inhabit patiently. This concept, the long now, applied to alien civilizations, transforms how we interpret evidence. A probe like 3i Atlas wouldn't be a quick scout. It would be a long-term monitor, part of a survey that might last millions of years, watching stellar systems as they evolve, life as it emerges, intelligence as it develops. Its arrival now might be scheduled, based on predictions made 1 million years ago, that a technological civilization would arise on Earth around this time. The wow signal fits this pattern. It wasn't the start of a conversation. It was a status check in a monitoring program that began before human civilization existed. We just happened to be listening at the right moment. The silent sense isn't silence. It's the program continuing according to its slow, patient schedule. For such a civilization, stars are temporary, planets change, but the network endures. Probes are replaced every few million years. Data is collected, compressed, and stored for eventual retrieval, even if that retrieval is 1 million years in the future. There's no urgency because time is abundant. This perspective makes our frantic searching seem naive. We look for constant signals because we can't imagine not needing constant confirmation. A long-now civilization doesn't need confirmation. It knows the universe is old and it has time to wait. The discovery of 3i Atlas might be our first contact not with a peer civilization, but with an entity so ancient and patient that we are like brief sparks in its long night. Our entire recorded history is a blink to them. Our hopes, our fears, our dreams, all are data points in a survey whose purpose we cannot fathom. If the galaxy is teeming with intelligence, why don't we hear them? The standard answers range from the dystopian, they destroy themselves, to the pragmatic, distances are too great. But there's another possibility, more subtle and more frightening. Advanced civilizations choose silence as a strategic imperative. They don't broadcast because broadcasting is dangerous. In a universe where others might be hostile, the smartest move is to listen, not speak. To hide, not reveal. This is the dark forest hypothesis, and it paints a grim picture of cosmic sociology. Every civilization is a hunter in a dark forest, knowing that others might be hunters too. The first to reveal their location risk annihilation. So, they stay quiet, monitoring others from the shadows, never speaking, never confirming their existence. In this model, the wow signal wasn't a hello. It was a mistake, a brief, accidental transmission that violated the rule of silence. 3i Atlas isn't a friendly probe, it's a stealth observer, designed to gather intelligence without being detected as artificial. Its natural appearance is camouflage. Its strange composition is a deliberate attempt to blend in. If this is true, then our own broadcasts are incredibly reckless. We've been shouting our location to the galaxy for a century, assuming that anyone out there is benevolent. We might be the naive children in a forest full of predators. The architecture of silence would be sophisticated. Civilizations would develop stealth technology for their probes, disguise their structures, use quantum communication to avoid detection. The galaxy might be full of activity, but all of it hidden, all of it designed to be invisible to newcomers like us. We don't see them because they don't want to be seen. The fact that we've detected anything at all, the wow signal, 3I Atlas's anomalies, might be due to errors in their concealment protocols, flaws in the architecture of silence. This makes the search for extraterrestrial intelligence not just a scientific endeavor, but a survival imperative. We need to find them before they find us. Or perhaps we already have. 3I Atlas is now receding into the outer solar system, becoming fainter, moving beyond the reach of our telescopes. We may never get another chance to study it closely. The data we have is all we will get, and that data is ambiguous, open to multiple interpretations. It is simultaneously a comet and an anomaly, natural and potentially artificial. Its story is unfinished. The real significance of 3I Atlas might not be what it is, but what it represents, a turning point in our cosmic self-awareness. It has forced us to look at the sky not as a collection of natural phenomena, but as a potential landscape filled with artifacts and messages. It has blurred the line between astronomy and archaeology. The convergence with Sagittarius and the wow signal might be coincidence, but it has shown us how easily coincidence can transform into pattern, how quickly the universe can shift from empty to full of meaning. We are left with questions, not answers, and that is the point. The probe, if it is a probe, wasn't sent to give us answers. It was sent to make us ask questions, to look at our place in the cosmos with new eyes, to realize that we are not just observers, but participants in a story much larger than ourselves. The story of 3I Atlas is unfinished because it is our story to continue. The next chapter depends on what we do next. Do we build better telescopes? Do we develop interstellar missions? Do we create protocols for contact? The probe is the question. Our future is the answer.